So if you have anything at all, make sure you stop me. All right, so I just recorded, hit record, and let me open up our chat. All right, so yesterday I gave you guys a bunch of information at the very beginning of the video, basically all like the equations you're going to need to know, formulas, equations, things that you're going to be using that had the vocabulary that goes with it, because vocab is very, very important as well for this section. All right, so my first one, it says that I have a ramp is 50 feet long and has an incline of 6 degrees. So it's basically saying, okay, like here's my like positive x-axis, so it's kind of my base, and then I have a vector or a ramp that's gonna be 50 feet. So it says it has an incline of 6 degrees, so they're saying like this angle right here is going to be 6 degrees. That's all. So it says a second ramp is 30 feet long and runs parallel to the first ramp. So I have another ramp that's going to be 30 feet long. I'm going to kind of just, and it runs parallel to this. So I could go ahead and I could say, well, then I have this ramp right here, and it's 30 feet. So parallel to the first ramp. So this is my first ramp. This would have been the second ramp. And I want to point out why that's going to be important. Let me double check what coming in or out. Okay. So to determine the vector representing the shorter ramp, what scalar must be multiplied to the vector representing the first ramp? So again, this is the vector representing my first ramp, and it's asking you what scalar. That's going to be some type of numeric number. It's always going to be a numeric number. Some scalar is what you multiply something by. And so it wants to know, what do I need to multiply this length of the first ramp, that 50 by, so that I could get my second ramp? So I need to multiply 50 by something so that I would get that ramp that's 30 feet. They want to know, well, what is that something? So is it going to be a number that's going to be less than -1, -1 to 0, 0 to 1, or greater than 1? So what do I need to multiply this by? Well, first of all, it's not going to be by a negative number because they're pointing in the same directions. If they were going in opposite directions, that's when I would think about using those negative values when we talk about vectors. So it's not going to be a negative number. It's not going to be either one of those. What I need to figure out then, is it going to be something between 0, 1, or 1? Well, think about this. If it's greater than 1, such as a number of 2, that would give me a value of 60. If I had this as a number 10, that would give me 500. So the bigger the number, the larger this value is going to be. The larger the number I multiply by my 50, the larger the number this is. So I could solve for this, and I can see if I divide both sides by 50, and I actually wanted to solve for that value, I would get that it's 0.6, but I should be able to tell if I want a number that's going to be smaller than what I'm starting with, then I need to do it with a fraction or some number between 0 and 1. So this was the correct answer. So I need to multiply this value by something that's going to be between 0 and 1 to get the smaller vector. All righty. So my next one, initial point and terminal point. Remember when we talked about these? So my initial point is the point that I'm starting with. This is the point that it's going to. So when I want to figure out what the vector is, so these are 2 points. If I want to know what the vector is, what my vector V is, that's going to equal, remember, the vector. And again, a lot of times it's represented with a bold. Like maybe if I do it in black, they just do like a bold letter that's saying that's the vector. And they use this notation of those brackets. So remember that when we find this vector, which we're going to do quite often in this unit, you start with the terminal side, the end side. So when we look at this, this is my ray. The terminal side is where it points to. The initial point is where the start of that ray is. So it's going to be, in this case, 6 minus a -5. So the first points go together and the second points go together. So it's going to be 2 minus a -11. So my vector V is going to be a negative, and negative makes that a positive. So it's going to be 11 and a positive 13. So vector V is 11, 13. Vector V is 11, 13. So what if I want to figure out the length of that vector? Notation. So we talked about this. Sometimes they use this double bracket. So this double bracket is sometimes just noted like this. It's not the absolute value. This is more often, but they use both notations in here. So I want to make sure to point this out, which is equal to the magnitude, which is just the same thing as saying the length of the vector. All this vocabulary, right? So that's the hardest part for all this is this vocabulary. So if I want to figure out the magnitude of V, the magnitude of V is going to be the square root of V1 squared plus V2 squared. Remember, this would be when I talk about V1 and V2, this is my V1, this would be V2. I'm talking about those points of A and B, X and Y, whatever you want to reference them to. It's talking about the first term squared plus the second term squared. So it's just going to be the length of this vector is going to be 11 squared plus 13 squared, which is going to be 121 plus 169, which is going to be the square root of 290. And I don't have to do anything else here because there's my answer. Done. So I needed to know what that notation means. They didn't say find the magnitude. What is the length? They said what is, and they gave you this notation. So you need to be able to identify it. All right. Consider the points Q and R. What is the component form of QR? So notice this notation, Q's first, and look at the way that this ray is above it. So this would be the initial point, and this would be what we would call the terminal point, because that's where it's going to. So they want component form, Again, vocabulary, what's component form? Well, luckily, if I look here, I can see this notation. It's all written the same. That's what they wanted us to do. Right here, we put this is in component form. That's what we did right here, was we put these 2 points, and we put the vector into component form. So the same thing's gonna happen here. Again, vocabulary though, knowing what they're asking. The idea you guys usually don't struggle with, it's the vocabulary. So QR, if I want to know what QR is going to be, it's going to be, I take the terminal, it's going to be 7 minus my 23, and it's going to be, so the first ones go together, the second ones go together, and then it's 62 minus 48. And when I do that, I get negative 16, positive 14, done. And we're on to the next problem. All righty. So we saw one similar to this yesterday. It says, what is the approximate direction angle of the vector? So remember that direction angle is going to be tangent inverse of my y over x. Well, what is that y over x going to be? What am I using for that? Well, for these, they're always going to give it to us at the origin. So when I want to find the vector, it's just going to be wherever this point is. So this vector is going to be at -2, -1. -2, -1. So if it starts at the origin, wherever it's pointing to is going to be the vector. I know that this is in quadrant 3, right? We're working here in quadrant 3. I'm in quadrant 3 here. The problem is that when we look at my tangent inverse, I know that my answer is never going to be in quadrant 2 or 3. So when I solve this, it's going to give me an answer here or here. I need to get it so that I end up here in quadrant 3. And that's what we had to do yesterday. We were given an answer in quadrant 4 and we needed to get it to quadrant 2. So let's look at how this works. All right, so let's plug in the values we know. I need to figure out my y and my x. Well, that's just talking about these points right here. So it's going to be tangent inverse of -1 over -2. So it's going to be tangent inverse of 1/2. I go to my wonderful calculator and I plug that in. So shift my tangent inverse of, I'm just going to do 0.5. It's 1/2. You guys 0.5, 1/2, same thing. And I get a value of 26.6. 26.6. Actually, I'm going to use just the value of 27 because I look up here, they're all whole numbers. So I'm going to just round to the whole number there. So I'm going to use 27 degrees. So I was just told that this angle is 27 degrees. Problem, because this is in quadrant 1. This is a vector in quadrant 1. I want a vector that's in quadrant 3. So what do? Well, here's what I know. Remember that this line for tangent, remember they're always a distance of pi apart and they're going to be the same value. So I can use that idea always. I'm going to extend out the line. And this angle is 27, so I know that this angle is 27 degrees. And this vector right here is the vector that's going to be directly across from it. It's going to be the vector going in the opposite direction. So what I need to figure out then is what is this angle right here? And I know from here to here is going to be 180. This is my 180 from here to here. And then this is going to be plus my extra 27. And so when I add them together, I get 207 degrees. So again, we're looking from here all the way to here. We're looking from starting from here all the way to here. We were able to evaluate that this is 27 degrees, so this has to be 27 degrees. From here to here, half a circle is my 180. So we needed to add them together and we got our 207, and there we go. These are the hardest ones. But remember, always continue. If you get an angle that's going to be in quadrant 1, and it will either be a quadrant 1 angle or it'll be in quadrant 3. If you get an answer that's in quadrant 4, it will be quadrant 4, or it could go across to quadrant 2. It's always going to be a diagonal across. It is in Q3, so 207 is in Q3. Okay, so when we say it can't be in Q3, when you evaluate it, your answer will never be shown. So when I plug it in the calculator, it's always going to give me a value between -90 and +90. It's always going to give me, when I evaluate the inverse, it's always going to give me the value here when I solve it. The problem is we actually want to know tangent of theta when it equals y over x, which happens at 2 spots. But when we look at evaluating this, we change it to the inverse to find that numeric value, and then we have to correlate it to the right quadrant. So when we solve it, it's always going to give us an answer that's here. When we use that inverse key, it's always going to give us the restrictions. But when we actually want to solve it, there's 2 spots. The calculator just can't give us both of those values. So it's super tricky in that concept, in that idea. So really tricky when we talk about those inverses. So always, 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 whether it's tangent, sine, or cosine, your inverse will give you one answer, but it does have a mate in one of the restricted regions. All right, and our last one for today. 2 pieces. What is the component form? So again, component form is when we're putting it into the little brackets like that. And what is the magnitude? Magnitude, what is the length of the vector? So component form. Well, when we've been doing component form, look, we were given an initial point and a terminal side, and we put it in component form. We were given an initial point and a terminal point, and we put it in component form. But in this one, all I have is a graph. That's because we can pick off those points. We can get the points ourselves. So when I look here at this point, this is my initial, this is where I'm starting, because I always start at the end point. And that point is at 6, 2. So they didn't tell me it, but I can easily identify it from the graph. And this would be the, where it's ending, that terminal point. Now remember, the graph's counting by 2s, so this is halfway. So I would say it's going to be a -1 and a +4. So those are the points that I'm going to use. So when I want to find the length of the vector, when I want to find, or actually, let's do the component, sorry. When I want to find the component of this vector, put it in component form. Remember, it's the terminal side minus the initial every time. Terminal minus initial. So it's -1 minus 6. So the first points go together. The second points will go together. So then it's going to be 4 minus 2. And I get -7, 2. So this is going to be, so I can see here my component form. Not going to be this as my answer. So again, this is my component form. I like to write this stuff down for you guys because I think the more that you see, the more that you start to correlate the vocab with the way the notation is. And then I need to find the magnitude. So the magnitude of V, magnitude, the length. Now remember, for the magnitude, it's going to be the square root. You square the first term, so -7 squared, plus you square the second term. Now remember, when we talk about your squaring the terms for the magnitude, it's always of the component form. It's always of that component, not a point, not a point. It always has to be of the vector, not a point. So the square root of -7 squared is 49 plus 4, and this is going to be the square root of 53. So I can see then, there's my answer. It's that square root, sorry you guys, square root of 53. Square root of 53. Any other questions, clarification? So those tangent ones are the trickiest. If you come across something today as you're working on it that I didn't cover, please let me know. Or if you're working on tangent one, you're like, is this correct or not? Let me know. I have a question. So it can't be one of these two because I'm sorry. I flipped it in my head. I wasn't paying attention. I lied to you. Heidi, thank you. It can't be one of those two. It has to be one of these two because that's what matches it. So my correct answer, thank you. So again, this is a -2, 7. I need a -7, 2. So it has to be one of these two. And this one has my square root of 53. So this is the correct answer. This is a big fat no. Thank you, Heidi. So again, these two are switched. It was -7, 2. So -7, 2, those have to be it. The first two could not be a valid answer. So don't make that mistake. Anything else? Anything else? Awesome. Thank you guys for your help today, for your questions today. If you need anything, again, please reach out. I'll see you guys. You're welcome. Have a wonderful day.